morning, class. Today I'm going to teach you about Kirchoff's law. So it's a way to solve non-simple circuits, so circuits with multiple loops, like our example problem right here. Kirchoff's law is broken down into two components: KVL, which is Kirchoff's voltage law, and KCL, which is Kirchoff's current law. Kirchoff's current law states that the current into a node equals the current out of a node. So right here you have a current flowing into the node and then two currents flowing out. So this current flowing in must be equal to the sum of the two flowing out. When solving, a negative current indicates that the current is in the opposite direction of what you assumed it would be at the beginning. Kirchoff's voltage law states that the sum of voltage drops across a closed loop is equal to 0. So this applies for a closed loop in a circuit, so from the positive terminal of a power source to the negative terminal. So to apply KVL to a circuit loop, you need to label the distinct points and calculate the voltage drops between these points. So for here, a distinct point would be this area here, and another distinct point would be here. So the only voltage drop in this loop is across this resistor and across that power source. Okay, now that you know Kirchoff's voltage and Kirchoff's current laws, we can go to an example. So we have this multi-loop circuit, two power sources. Here I labeled all three currents, I1, I2, I3. I assume the directions, and our results will tell us if I assume correctly. I pointed out two different loops, loop 1 and loop 2, and I labeled distinct points. We have A, B, C, and D. So first we go to KCL, and we pick a junction. I'll pick A. So the currents flowing in must equal the currents flowing out. So I1 plus I2 has to equal I3. We could do the same for junction C, but it would turn out to be the same as junction A. So now we go to KVL. For the first loop, we look at the voltage drop between B and A, the voltage drop between A and C, and the voltage drop between C and B. And then for the second loop, we look at the voltage drop from D to A, then A to C, then back to C to D. Plugging the numbers in for that, we get three equations. I1 plus I2 equals I3. We have 10 times I1 plus 10 times I3 minus 10 volts. Because we're going backwards across a battery, it's a negative current drop because the current is rising. And our third equation is 10 times I2 for this resistor plus 10 times I3 for this resistor minus 12 volts again. Going from negative to positive on a battery gives a negative current drop. And what you have to do now is solve this system of three equations. And I'm not going to teach you how to do algebra. This is our result. Solve for I1, I2, and I3.